There once was a crazy old cat who would practice his math while he took a bath. He did all kinds of math, but his brain would malfunction, except when he did Intro to Functions. While in the bath, he learned lots about math, beginning with the pieces of the graph.
There are zeros, y-intercepts, a min and a max, asymptotes, turning points, no time to relax. With all of this info, he could not abstain from finding the wonderful range and domain.
Once finding all of the graph's components, the cat's good friend Fish came over for a few moments. The cat then asked Fish which of the following is a function. Is it A, B, or C? Please don't make an assumption.
C is the answer, the smart fish declared. It's the only relation where the x value's not shared.
The cat then said, tell me this function's inverse. Don't think too hard that you'll need a nurse.
A is the answer. I know this is true. Simply switch the graph's x and y values.
You're smart, the cat said with an exclamation. Now list in order a graph's transformations.
First you state the horizontal compress or stretch. Then you see if it was shifted to the right or the left. The A value then vertically contracts or expands. Then the C value shifts up or down. Don't misunderstand. The fish then said, please, I have a confession. I simply can answer your every question. Now I will give you a challenging test. It will be difficult, so just try your best. Please tell me what makes an odd relation?
About the origin, there is symmetric rotation.
What about the other one, an even one that is?
It's where a function is symmetric about the y-axis.
Now let's tell the world all that we know. My brain is about to overflow.
But wait, Cat cried, we can't forget the infamous functions that are periodic.
Together they remembered where the functions are concave. They plotted the points of the cos and sine wave.
Together Fish and Cat thought they were so intelligent until they met Mr. Elephant.
The elephant said, I know you're smart, so I'll be optimistic. Graph a function that displays the following characteristics. It has 3 zeros and a local max, landing at x equals 7. Y is an element of R, so you'll have to look far for the intercept at y equals 11. Don't forget the local minimum at x equals -2, so plot the points and draw the graph. That's all you have to do.
What? Cat and Fish stood still and stared. They were both beyond confused. The elephant laughed in delight. He was clearly quite amused.
I am smarter than you, Elephant declared. Cat and Fish's feelings certainly were not spared.
The two friends chose to then go home, but they would not be overtook. They first sat down, got a calculator out, and opened their math textbook. And here are some things that the cat and fish may have forgotten to mention during their story. Boo.
We are now going to look at a question that would typically be covered in Unit 1 Intro to Functions. The question asks us to sketch the curve, state the amplitude, period, domain, and range of the function. The function reads f at x equals 3 sine 2x plus 360 minus 2. So, to begin, we need to factor out the k value so we can determine the true period of the function. So, we'll have 3 sine, the 2 comes out of the brackets, and we're left with x plus 180, because 360 divided by 2 is 180, minus 2. Now, from this, we can determine that the amplitude of the function will equal 3, and we also know that the period, of course, is 360 divided by 2, which equals, as we determined already, 180 degrees. Now we can go ahead and do the mapping rule for this function. So we start with x, y. Now we have a horizontal compression by a factor of 1/2. So we have 1/2 x plus, minus, we'll make that a minus, 180. And to the y's, we have a vertical stretch by a factor of 3 and a shift down by 2. We will now make our original table that will help us plot the points when we go to draw the graph. So we start with 0 degrees, 90 degrees, 180 degrees, 270, and 360 degrees. And for the y values, the sine wave begins at 0, then goes to 1, returns back to 0, down to -1, and then again to 0. Now if we make the graph, the table of the transformed function, we have 1/2 x minus 180 as we determined in the mapping rule, and 3y minus 2. Now 1/2 times 0 minus 180 equals -180 degrees. 1/2 times 90 minus 180 equals -135 degrees. 1/2 times 180 minus 180 is -90. 1/2 times 270 minus 180 is -45 degrees. And 1/2 times 360 minus 180 is 0 degrees. Now we know that our y values, 3 times 0 minus 2 is -2, 3 times 1 minus 2 is 1, 3 times 0 minus 2 is again -2, 3 times -1 minus 2 is -5, and 3 times 0 minus 2 again is -2. So now we can go ahead and make our graph. And we can go up by intervals of 45 degrees. Now we have 135 degrees and 180 degrees. -45, -90, -135, and -180 degrees. And we can go up by 1. So we have 1, 2, 3, 4, 5. -3, -4, -5. And now we can't forget to draw our arrows on the graph and label our axes. X-axis, Y-axis. Okay, and now we can go ahead and plot our points. So at -180, our graph goes down to -2. At -135, our graph goes to 1. At -90, the graph goes to -2 again. At -45, the graph goes to -5. And at 0, the graph is at -2. And now we can draw our wave. And we know that because it's a periodic function, it would repeat itself. So now we can determine from this, we've already stated the period and the amplitude. And now all we have to do is state the domain and the range. So the domain equals x is an element of real numbers. since these x values continue to the positive and negative infinity. And we can also determine that the range y is an element of real numbers such that we know that it doesn't go past -5 and it doesn't go beyond +1. So -5 is less than or equal to y, which is less than or equal to +1.